Hey guys, Mr. Riss here to help you out with the optional review for chapter 6. So this is just like your test, just with different numbers. So it's a great way to use this as a practice to make sure you guys are ready for the test. All right, so going through these problems here. First one here is to determine whether this function shows growth or decay. I guess what you can always do is just type it into a calculator and see graphically, does it go up or does it go down? The other way to look at the formula, though, is if you just look at the number here, the B number, the number in the parentheses here, if that number is less than 0 or less than 1, that is a decay. That number is bigger than 1 or less than 1, so it's decay. If it was bigger than 1, it'd be a growth. All right, with the parent function, y equals 2 to the x power, write equation that has a vertical shift up 3, so that's our k number, and then a horizontal shift to the left 11. All right, so we'd have y equals 2. We'll take care of the easy part. It would be plus 3 at the end. And then to make it go to the left 11, we'd have an x plus 11. The left is always, or the horizontal is always opposite of what we normally think. Negative would go to the right, positive would go to the left. All right, graph the equation here. And you have a horizontal asymptote. The horizontal asymptote, which would be the lowest point of this graph, would be y equals right here, okay, -3. So we'd have it right here at -3. Next, what we could do is make a table here to help us find some other points. Now, normally we start at 0 and do some above or some below, but we're actually going to shift that over 2 spots. So we're going to put -2 in the middle, go up, and then go down. Okay. And so we can use a graphing calculator here to help us out, but I'm going to try to do, well, now let's use a graphing calculator. So Desmos would probably be really helpful for us here to get these points. We'll go here, just go to Desmos. Yeah, because the equation is pretty crazy. We got -2 to the 1/4, so we're going to have a decay problem to the x plus 2 power. Ooh. Oh yeah, we got to put that in parentheses on Desmos. -3. And we will convert to a table. All right, so I already got those on here. You know what, I'm just going to take these in -4. Oh, that's not -4, -4, -3, -2, -1, 0. Might as well put +1 up here as well. There we go. So if we try to graph some of these numbers, we got -35, -11, -5, -3.5, -3.125, and even at 1 is -3.03125. So very small. Let's try to plot those points. Okay, so -435 is definitely off the charts here. -311, can we fit that in? 3, 6, okay, 7, it would still be like even up here. All right, -25, so -2 up, or actually no, it's down, negative. So it'd actually be below the graph. So -2.5, left 2, down 5. All right, -1, -3.5. -0 is that, okay, so there we go. Now we're trying to get in. So the graph is going to start off like this, very close to that, and all of a sudden just pick right up. There we go. Biggest thing here is you guys have the table, and then the horizontal to asymptote is always whatever the k number equals. All right, now how do we solve these using common basis? So it says common basis, but then check your solutions here. So 2 to the x power, all right, 64. So it's going to be 2 to some power that's going to be negative. So take a look at your chart, plug it into the calculator a couple times. All right, guess and check if you don't know. Okay, how about 2 to the 6 power is 64. So this would have to be 2 to the -6 power. Cancel them out here, and so x would have to be -6. All right, 25, that does not turn into 125. 25 squared is 625. So we actually have different bases. The basis would be 5. 5 squared would give me 25, the x plus 1 power. And then 5 cubed would give me 125. All right, so bases cancel out, and we got a 2 times x plus 1 is equal to 3 times 3x. So distributing the 2, we got a 2x plus 2 is equal to times the 3, 9x. So 2x would equal 7. Divide, x would equal 2 over 7, whatever decimal that is. All right, change it to exponential or vice versa. So these are our loop and swoop problems in problem 5. So we'd have 7 to the 3 power equals 343. And you can just check that on a calculator. Type 7 to the 3rd power, 343. It works out. All right, loop and swoop this one here. So now we have what we're going to turn into log. So log base, the first number is 6, so it's down on log base 6 of, we touched the 1 over 36 is equal to -2. There we go. Not too bad. Hopefully the problems or the test is pretty easy. All right, next, how do we solve these here? Okay, we're going to loop and swoop when we can. So loop and swoop. So that'd be 8 to the 3rd power equals y. Just take out the calculator. What's 8 to the 3rd power? Fairly high. It's 512. All right, next here, can we loop and swoop? Yeah, technically we can. All right, so this would be 4 to the x plus 7 power equals 1024. Question is, okay, what's 1024 to? So 4 to what power? 4 to the 4th? No, 4 to the 5th. There we go. So it'd be 4 to the x plus 7 power is equal to 4 to the 5th. Could cross that out and say x plus 7, because we had common basis, is equal to 5. X would equal -2. Now, what you could have done as well with that problem is you could have just gone in and with the math used the calculator here, log base button, and did log base 4 of 1024. Figured out that that is 5. So you could have just figured out, okay, this is 5 equals x plus 7. Gone through and subtract. So common bases are nice. Calculator, if you show your work, can be a whole lot easier. All right, next, we have common bases on both sides. We got 1 log here, 1 log here. They're both the same logs. They cancel each other out. So we get a 5x plus 9 equals a 3x minus 9. Minus the 3x over, that's a 2x. Minus the 9 over, that's a -18. X would equal -9. Now, when we have multiple logs, we got to turn them into 1 log before we cancel out. So this would be a log base 10x plus 2 divided by 2 equals log base x times 3. Now we have a 1 log on this side, 1 log on that side. They're the same log, they cancel. So if we divide this by 2, this is a 5x plus 1 equals 3x. Can subtract that over, we get a 2x plus 1 is equal to 0. Add or subtract the 1 over, it's -1. Divide by 2, we get -1/2 as that answer. Not too bad. Okay, ooh, I'm missing a point there. Is that just supposed to be an A? Yeah, I think so. Let's just make that a regular A. All right, solve each equation. Okay, so if we have a log here, we need to isolate it before we start moving things. So let's subtract the 5 over, so we get -6 log base 3 of a minus 12 is equal to, subtract the 5, that's -9. All right, next, let's divide by -6. So we have log base 3 of a minus 12 is equal to, if I take 9 divided by 6, or -9 divided by -6, that becomes a positive 3 over 2. All right, next, let's loop and swoop this here. So we got a minus 12 is equal to 3 to the 3/2 power. We're going to get a decimal here. All right, so we're going to take out a calculator here. What's 3 to the 3/2 power? That is 5.1962. We'll add 12 over, 17.1962. What we can always do is just take a couple seconds to plug that in to see if that's right. All right, and from here, we need to isolate this e first. So we're going to add 11 over. So 4e to the x power is equal to, all right, if we add 11 over to 17, that's 28. Divide by 4 to get the e to the x alone. 28 divided by 4 is 7. And then what cancels out in e? The ln cancels out. So we take the ln of 7. So we take out a calculator again. Natural log of 7 is 1.9459. So once again, we got natural log of e to the 7th minus x equals 17. Natural log and e's cancel each other out. So this just becomes 7 minus x equals 17. Only thing you got to be careful here is you're going to subtract the 7 over. So you get negative x is equal to 10. X would equal negative 10. Be careful with the negative sign. This problem here we have the natural log, but no e, so we got to isolate this natural log. So we'll add 3 over, we get the natural log of 2x plus 11 equals 3. All right, to get rid of this natural log, to make this just a 2x plus 11, we need to do e on the other side. So calculator time, what's e to the 3rd power? I got 20.0855. So if you think about what we'll have to do next is to subtract the 11 over and then divide that answer by 2. So I'm just going to take my calculator out, minus 11, and then we get 9.0855. We'll divide that by 2. So x would equal 4.5428 when we round. So hopefully those problems aren't too bad. You know, little tricks to them. They should be fairly easy answers. And you can always plug them back in to see if they're right. All right, last question here. There we go. Give you a little clue here to help you with the formula, but I have a student loan for $30,100 with the federal government that has a yearly interest rate of 4.7% that compounds monthly. This is the average according to the U.S. Today student loan debt. I defer payments for 6 months, average time for students get after they get a job. What is the amount of my loan when I start my payments? All right, so what we'd have to do is to figure out, and this is what they do, you'd have $30,000 in student debt. So that is your principal. Your amount is what we're going to try to solve for. So $30,100. We got 1 plus. The rate is 4.7%. So that means R is 0.047. Divided by N. N is number of times the interest is applied in a time period. So N, it's compounded monthly. So N would be 12. And then T is the time period that it elapses. Now, normally here it says for 6 months here. So we're going to go ahead and plug 6 in. Now, here we go. Let's go through and figure this out. Actually, no, I messed that up. It's not going to be 6. Time period is, if we're in for years, be 1/2, right? Yeah, 1/2. Because if we got 12 times in 1 year monthly, we're going to times it by 1/2. There we go. Okay, so let's make our life easier by breaking this up into just smaller chunks. 2 small chunks that we can do is we can type this part into the calculator. What's 1 plus 0.047 divided by 12? And I get 1.0039166667. And then, well, the other chunk we can do is the 12 times 1/2, that's 6. All right, so what we want to do next is we're going to multiply, or we're going to take that decimal to the 6th power. So in the calculator, I'm just going to do to the 6th power. We get 1.023731309. And we're going to times that by the $30,010. $30,100. And so the entire amount of the loan is $30,814.31. Not too bad. So $700 more because we couldn't pay it up front. So student loans aren't usually too bad. That's only if you wait 6 months after your last bill is due. Now, the one thing about student loans, though, is that they do start. So if you take student loans out your freshman year, that time period just keeps improving. And then you have your sophomore year, so then the loan gets higher, and then your junior, and then your senior, then you had a party year, so you got a 5th year, then you wait 6 months. So sometimes your loans, parts of it have accumulated at the start of your freshman year. So it's always good when you get to school, you know what you're doing, you pay as much as front as you can, and you try to graduate early. Otherwise, you'd be paying so much. Now, this isn't too bad if you had just $30,000 right at the end and you only had 6 months to get ready for it. But it's a decent car payment then. All right, you guys have a great day. I will see you next time. Good luck on the test. I think you guys will be doing all well on this. Double check. Yep, there's nothing else. If you guys have any questions, ask, and make sure you got your work turned in. Have a great one. Good luck.